Okay, start recording. Good. 3, 2, 1. Yes. Okay, now, so we come back to the second part for today. So, if you take a look in the book, so you can see that we still have 2 sections left for for chapter 8. So we're gonna have section 8.5, the ratio test, root test, and comparison test. And section 8.6 is alternating series. So the content that we're gonna learn start from now gonna be for the midterm exam. But I mean you learn first, but it's gonna be test on in March for the midterm exam. So what are we going to learn next is we are going to learn 3 more tests, which is going to call ratio test, root test, and comparison test. This is going to be the one that you're gonna use to check the convergence and divergence of the series as well. And then section 8.6 gonna be the one that we learn how to deal with the alternating series. This is going to be the case that you're gonna face -1 to the n in the series. And then if you wanna learn how to deal with the alternating series, it's gonna be section 8.6. Okay, so I will tell you that these 2 sections, the content is a little bit tough because you're gonna it's require a lot of simplification, so you need to be good at cancellation and simplification. And then you're gonna see in a little bit that if you are not good at expand or cancellation things, it's gonna be hard to understand this section 8.5. Okay, first of all, let's take a look at the root test. So the plan for today, I hope that we can finish the ratio test, and then we're gonna just move to the root test a little bit for today. So what is the ratio test? So this is a theory behind the ratio test, but basically let me give you the statement of the ratio test first. So you can move to page 3. Page 2 is just the idea. I'll come back later. So this is the idea of the ratio test. If you have a subscript k summation infinite series with all positive terms, and then you take limit of a subscript k plus 1 over a subscript k, you take limit of this one, and then you get r. You can figure out the convergent and divergent pattern by looking at the r value. If your r, that your limit that you get is between 0 and 1, it means the series is convergent. If your r is bigger than 1, it means the series is divergent. If your r is equal to 1, the ratio test is inconclusive. So you have to use another test. This is going to be the statement of the ratio test. Why this is true? You can imagine that if a subscript k plus 1 over ak, you take limit and then you get r. I mean approximately r, it's gonna be, when k is getting big, r gonna be approximately ak plus 1 over ak, which means ak plus 1 gonna be approximately r times ak. And if you plug in this thing back into the original series, you can read the previous page by yourself. If you plug in back, you plug in ak plus 1 by rak. You plug in ak plus 2 by r square ak, and so on. And then you pull out ak, it's gonna come back to the geometric series, which means it's gonna be convergent when r less than 1. It's gonna be divergent when r bigger than 1. So that means if you have r value by taking the limit here, and you can figure out the convergent and divergent by just taking a look at r. This is so powerful. This is called the ratio test. Why it is so powerful here? Because when you see something that you can easy to compute limit ak plus 1 over ak, you can apply the ratio test. The thing that you're going to use a lot with the ratio test is when an has factorial. For example, if you have factorial in there, so you don't know how to deal with the factorial because you cannot integrate the factorial. So mostly when people see factorial, they're going to use the ratio test. It's going to be useful in that case. but you can apply the ratio test in so many ways. So if you see the exponential function, it's gonna be useful as well. So let's take a look at the ratio test first. So I'm pretty sure after 2 examples you feel much more comfortable with the ratio test. So first of all, let's start by example 1 here. I want you to use a ratio test to check that the series is convergent or divergent. So k over 2 to the k start from 1 to infinity. How do you apply the ratio test here? So first of all, you take a look. This is your AK, right? This is your A subscript k. So you're gonna take limit of AK plus 1 over AK. And then you're trying to compute the limit of this one. If it is less than 1, convergent, bigger than 1, divergent, equal to 1, no conclusion. Okay, so that is all you need to know. So compute this limit R. Hopefully it's gonna be something bigger than 1 or less than 1, so you are done, and then you know that it is convergent or divergent. So some of you are gonna have a hard time when plugging in. If you don't know how to plug in, just keep in mind that I need to plug in two things. So AK plus 1 and AK. So AK plus 1, it means you plug in K plus 1 into the function. So it's gonna be K plus 1 over 2 to the K plus 1. And A subscript K, it means you plug in K there. So it's gonna be 1 over 2 to the K over K. Oh, sorry, K over 2 to the K. K over 2 to the K. Just to make it more simple, so you can flip 2 to the K to the top, right? So let me move this thing a little bit. I need the limit sign here as well. So if I move 2 to the K to the top, so it's gonna be 2 to the K over 2 to the K plus 1. Group it up together, and then K over K plus 1. Group it together. Does it make sense? I just simplify. Oh, sorry, K plus 1 over K. K plus 1 over K. So basically what I did, I just moved K plus 1 and K together. So let's go here. And then 2 to the K and 2 to the K plus 1, I group them together here. So what is the limit here? Anyone can? I mean, right now, I don't want you to feel panic with the limit here. If you feel like you can get the answer with the limit here, just give me the answer. But if you want to show your work, you can show your work. But if I were, let's say I am a good student, like I am, how do I say, I am like Pawat or Tirame, like the good student, like you can see like, hey, this limit is 1, right? Because it's like K go to infinity, this gonna go to 1, right? Because this is K plus 1 over K, this go to 1. And then 2 to the K and 2 to the K plus 1 are gonna cancel. And then you get 1/2, right? Because this is like 2 to the K times 2 to the K times 2, right?
Yes, sir.
So 2 to the K cancel out. So basically this gonna cancel, and then you get 1/2. But this one limit gonna go to 1, right? You can just take a note here, and then, oh, because this gonna cancel out, and then you get 1/2, and that limit go to 1. So here the answer is 1/2. And then less than 1, which means R less than 1, so the series is convergent. Very simple. The series is now convergent by the ratio test. So the idea is the ratio test, they're trying to compare the term K plus 1 and term AK. And if you get some number less than 1, convergent, some number bigger than 1, divergent, equal to 1, unlucky, that means no conclusion, you have to use something else. Does it make sense? So this is called the ratio test. I will let you jot down a little bit, but the idea is trying to make a lot of cancellation. Or you can see that 2 to the K here cancel with 2 to the K plus 1, so it's cancel, and then you get 1/2. I will show you the next question, maybe the factorial one, the one that students have a hard time with. Okay. All right, good. Well, we're gonna move from the easy one ratio test to the medium one. How about 10 to the k over k factorial? K start from 1 to infinity. This is your AK. So you're gonna use the ratio test. So R gonna be limit AK plus 1 over AK. So give yourself a minute. Try to cancel and compute your limit here. We're gonna just start by plugging in k plus 1 there. So it's gonna be 10 to the k plus 1 over k plus 1 factorial. And then that it's going to be k factorial over 10 to the k. Alright, the first step, you should get that one because a to the k plus 1 that I highlight in yellow, it's here. The one that I highlight in green, ak, it's gonna, when you flip it back, so you're gonna get here. Right? Right now, you need to do some cancellation. So first of all, 10 to the k plus 1 gonna cancel with 10 to the k. You get 10. Right? So you know that you have 10 on the top already. How about k factorial and k plus 1 factorial? Yeah, you get k plus 1 here and here. Cancel k plus 1. If you feel like, Ajahn, I don't know how to cancel the factorial, think this way. K factorial over k plus 1 factorial. This is the same thing with k factorial times k plus 1 times k factorial. And then that means you can cancel k factorial. Something like you have 3 factorial over 4 factorial. It's going to be 3 factorial times 4 times 3 factorial. And then you cancel. It's going to be that number, k plus 1. So at the end here, so you're going to have limit of 10 over k plus 1. K go to infinity. This is actually 0, less than 1 as well. So the series is convergent by the ratio test. Converge by the ratio test. Some of you gonna say, Ajahn, it look like it's so easy. Can I use a ratio test when I do the exam one? I mean, I will state in the question that use integral test, so you have to use integral test. If you use ratio test, you get 0, because I want to test you on the integral test. But you know, ratio test is easy to use. You can see compare to integral test, you don't have to integrate it. So it's technically it's easier. But you know, some function that you cannot, some function when you take the ratio test is gonna be 1, 1, 1, 1, 1 all the time, and then you cannot apply the ratio test. Remember the function that the series that we just did the integral test here, k squared plus 4, k start from 1 to infinity. If you feel like, Ajahn, can we just avoid the integral test? We're gonna do the ratio test. Well, if you do the ratio test, the limit of a is k plus 1 over ak gonna be 1. And then when limit is equal to 1, no conclusion. So you have to use something else. Alright, so if you feel like you want to get A for this class, let's challenge yourself by doing part C. This is the A level question. K factorial on the bottom, k to the k on the top. K start from 1 to infinity. Let's try to use ratio test for this one. This should be like the A level question. So what if you see this limit and then you try to compute? How do you cancel out? Alright, we're gonna just say that this is my AK. And then now you need to take limit, right? R equal to limit AK plus 1 over AK. K go to infinity, okay. Let's see how do we cancel that one. So k plus 1 to the k plus 1 over k plus 1 factorial. This is actually just AK plus 1. And then you have k factorial, k to the k, okay. The green one is the top here, and the yellow one is, whoops, sorry, okay. Okay, the yellow one is here. All right. of course you have to deal with the k plus 1 first. I mean, some of you are gonna say, Ajahn, the thing that we see clearly is like k plus 1 and k plus 1 factorial and k factorial are gonna cancel. So that one you can do pretty quick. So what if you do this one first? You move k factorial and k plus 1 factorial together. This is going to be the term that you can see the pattern easily, because this is gonna cancel to k plus 1 in the bottom, right? This is just like the easy part. But the hard part is like, what is k plus 1 to the k plus 1 over k to the k? Alright. One thing that you can do is, why don't we just pull out k plus 1 first? Because here we have k plus 1 to the k plus 1. It means k plus 1 to the k times k plus 1, right? Can I just change plus 1 here and do k plus 1 here? And then because I see k plus 1 over k to the k together, I mean, I see this term and this term, you can group it together. Why not? So we're gonna just do limit. Oh my god, that term cancel out as well. So 1 over k plus 1 for the first term. And then the second term we have k plus 1 over k to the k, and then k plus 1 again. So this term cancel as well. So basically you only have k plus 1 over k to the k. Limit k plus 1 over k to the k. In other words, it's gonna be 1 plus 1 over k to the k, right? Sounds good? It looks easy, but I mean, like when you see more complicated function inside there, so you just need to make a lot of cancellation. Now we're gonna just take this limit. What is the limit here? So when you're trying to plug in k equal to infinity, so it's gonna be 1 plus 0 to the infinity. So it's indeterminate form. So you have to take log and then compute the limit. Apply the L'Hopital rule. So still, okay, let's try to compute it on the left hand side here. We're gonna just do the log of limit 1 plus 1 over k to the k. So take log first, and then I will switch limit and log. So limit this is a technique that we learned before, and then we're gonna just move k down. So it's gonna be log k, right, times sorry, not log k, it's gonna be k times log 1 plus 1 over k. Now this is actually the indeterminate form 0 times infinity, and then now you just switch it to limit, keep log on the top, and then move 1 over k to the bottom. This is now indeterminate form 0 over 0. And then now you apply the L'Hopital rule. So you're gonna get the limit k to infinity. So differentiate log. So you're gonna get differentiate, let's say this is 1 over k. Just save the space. So differentiate log 1 plus 1 over k. So you get 1 over 1 plus 1 over k. And by differentiate using the chain rule inside, you're going to have minus 1 over k squared. And then differentiate 1 over k, so I'm gonna get minus 1 over k squared as well. And then now this term gonna cancel out. Good for me. So I only have 1 over 1 plus k now, and that means the limit is 1. right? So the log of that limit, the log of limit is 1, which means the limit here that I wrote in green here should be e to the 1, which is e. And once I get e there, so which is bigger than 1, so which means because r greater than 1, we conclude that the series, the given series, is divergent by the ratio test. Yeah, this type of question a little bit harder compared to before, because you have to once you simplify, you hit the L'Hopital rule, and then you have to adjust the limit by using the L'Hopital rule one more time. But at the end, once you get your r, so you get something bigger than 1, so it's gonna be divergent by the ratio test. So I went pretty fast on here because this is the old content that we learned last time. But you know, you can just here actually, you know, if you do the full thing, you have to expand the domain, and then you have to expand to x, and then you just do the L'Hopital rule. But this is the content after the first exam, so we're gonna treat k as something that is not the natural number. So it means that you can just take the L'Hopital rule without saying it is x. We understand in this room that we understand that, hey, I mean, to do it in proper way, you just need to expand the domain and apply the L'Hopital rule. But this is our shorthand notation that we can take limit k go to infinity. So yeah, this is a solution for this question then. So divergent by the ratio test. I think this is the last question for ratio test. Good. Exhausted, some of you say. All right, so well, before you go, so we have 10 more minutes, so we're gonna just show you the root test as well. So the root test and ratio test, same conclusion. Yeah, I mean, I will just make it more cleaner and post it to you later. So the last one is root test for today. The root test is the one that now this time you don't do ak plus 1 over ak. Now this time you do just ak, and then you take the k root, and then you take limit. You call this thing row. This thing gonna call the root test. The conclusion gonna be the same with the ratio test. P less than 1, convergent. P bigger than 1, divergent. Otherwise, no conclusion. That is the root test. Similar to the ratio test in terms of you have the same conclusion. P bigger than 1, divergent. P less than 1, convergent. P equal to 1, no conclusion. When do you use the root test? Of course, when you see a subscript k equal to something to the k. Something to the k. This is the best way to use the root test, because when you apply the root test, a to the k, the k root gonna be something to the k, and then you take 1 over k. So k and 1 over k gonna cancel out, and then you get only something inside there. So every time when you see the series with something raised to the k power, something raised to the k power here, always use root test. Is gonna be okay for you. Here you can see you can apply the root test. We're gonna do it later. Yeah, only 2 examples for this one, because the root test is so clear to use, because you see the pattern immediately that they have something to the k power. So let's try to do this example 2 together. So what if you wanna check the convergence of the series here? So you can trying to say, oh, my AK now is 2 to the k square plus 1 over k square plus 4 to the k. And if you know nothing about this question, I mean, if I didn't tell you beforehand that you have to use a root test, you have to think this way, that okay, when I want to check the convergence of this series, I have to think, can I use the telescopic series? No way, right? Because how do you just separate and then cancel out? This is not geometric series as well. No. And then can you use a divergence test? Take the limit and this is not equal to 0? Maybe, but something raised to the k is something that make you a little bit harder to take the limit. So divergence test is way too hard. So, or maybe you can use the integral test. And then I don't want to integrate this thing for sure. The integral test, just leave it no. But when you, now it's come to the ratio test or root test. Ratio test is just like, possibly ratio test is it's good, but it's gonna be a lot of calculation because you have k here. But the root test is more it's more compatible with, like, perfect for this question. Why? Because when you compute limit of ak, the k root, it's gonna be to the k, and then you raise everything to the 1 over k because of the root test here, and then k and 1 over k cancel. So you get limit k go to infinity 2k square plus 1 over k square plus 4. And the answer is here is 2. Bigger than 1, so the series is divergent. Diverge. This is why I told you earlier on the first day that series is hard, because you learn so many techniques: telescopic, geometric, divergent, integral test, ratio test, root test. Next week you're gonna this Wednesday you're gonna have the alternating series test, and like you have so many tests here compared to you learn in Cal 1, you learn integral technique, right? You learn by part, partial fraction, you learn trigonometric substitution a lot. Same thing here, the series, you have so many tests to do it. And if I don't tell you earlier which one that you have to use, it's gonna be super hard because you have so many tools to use, and then it's gonna be confusing which one that you have to use. So we're gonna wrap up the class today by looking at example 2b. This is the last one for today. Let's try to do the root test here. ไม่ทันเหรอ เอานี่เหรอ กลัวไม่เห็นนะซูมอยู่นั่นนะ ซูมไปซูมมาจนเด็กงง มันบังเพื่อนเหรอเนอะห้องเนี้ยเพราะว่ามันit is not a slope room นะมันบังเพื่อนใช่ไหมครับ alright so 5 more minutes for today. Let's compute part B and then we're gonna just end the class today. So question 2b here, let's do the root test for this one. So here a to the k is ak is k square over 2 to the k. So this is ak, okay? And then now you want limit of ak and then the k root. You do the limit k square 2 to the k and then raise to the 1 over k. Ratio test is much easier for this question, but we're gonna use the root test here. So the bottom part you're gonna have only 2, agree? Because 2 to the k and then you're gonna cancel with 1 over k, so it's gonna be just 2. The top part you're gonna have k over 2 over k, right? So far, so good. Good, nah? Everyone agree? I mean, I'm good because this is like just simplify, just simplification. And then now, so you're gonna have 1/2 limit k to the 2 over k. This term, of course, this is the term infinity to the 0. Need to apply the L'Hopital rule. So take log first. Take log limit first. And then now swap limit and log. And then now move move 2 over k to the front of logarithm 2 over k. Log k. Similar to your homework, right? I mean, that's gonna be one question on homework that I ask you to do k raised to the 1 over k. So this is kind of similar to that one. And then now it's gonna be 2 log k over k here. If you do the L'Hopital rule now, because it's infinity over infinity, so it's gonna be 2 over x and 1, not 2 over x, 2 over k. We use k now, and 1. So this is actually the L'Hopital rule now. And then now this is actually 0, right? So once you get 0 over there, so it means just limit k2 over k here, gonna be e to the 0, which is 1. So once we have this limit equal to 1, therefore the limit of root of k, the k root of ak, it's gonna be 1/2 times 1, which is 1/2, right? Because when you get 1/2 here, 1 here, you plug in back here, that I highlight in green, you plug in back over there, so it means it's gonna be 1/2 times 1, which is 1/2, and that is less than 1, and it means the series is convergent by the root test. All right, so that's the end of this question, part B here. To sum up what you learned today, you learned 2 more tools, ratio test and root test. This is the one that you can apply to check the convergence and divergence of the series by looking at the limit of ak plus 1 over k or the ak to the 1 over k. All right, what happened is now you don't have to be worried much about root test and ratio test. So your focus now should be on the homework one and trying to review everything start from the first day to the integral test to the P series. This is gonna be the exam one that is coming up next week. So I think that the good strategy is focus on exam one first. This content we're gonna just have the review for the midterm later. So we're gonna keep learning. I'll see you on Wednesday. Wednesday we're gonna start learning the comparison test and alternating series. That's the plan. All right, so everyone, so we're done for today. Thank you everyone for showing up.